Hello to everybody, welcome to my channel. Today I'm talking about what is a vector database, and it is very fun and very cool. Okay, first things, what is a vector database? Section 1. A vector is a set of numbers that represent the character of an object in a multidimensional space. For example, when converting an image into a vector, each number can represent the intensity of pixels color. Okay, and I want to show you brainstorm of vector database. Vector database for data storage. This is the internal structure of vector database. This is where and how the vector data is stored in a system. Since vector database deal with high-dimensional data like images or text, efficient storage techniques are needed to maintain performance and scalability. Two sections in internal structure of vector database is indexing and retrieval. What is the indexing and retrieval? Indexing is a process of organizing the stored data so that it can be searched and retrieved efficiently. Retrieval refers to how the system finds and delivers the most relevant data based on a query. You can using this method in your project for searching query and another sense. This is very fast and speedy. Similarity metrics. These metrics are used to measure the closeness or similarity between vectors, determine how similarity to pieces of data are based on their vector representation. Distributed architecture. A vector, a database often need to handle large-scale data and high traffic. A distributed architecture ensures that the database can scale, remain fault-tolerant, and handle heavy workloads across multiple servers or nodes. Because we are using a vector database in AI project for this distributed architecture. Query engine. The query engine handles user requests and find the most relevant result by comparing the input query with stored vectors. It is responsible for processing the query and ranking the result based on similarity. Integration with machine learning. Vector database integrated with machine learning pipelines by using ML model to create vector embedding and manage data storage and retrieval in conjunction with this model. Performance optimization. To handle large-scale data and provide efficient real-time search, vector database employ various optimization techniques to improve speed and reduce latency. This is all internal structure in vector database. As far as I know, I show this slide. Why is vector data important? So one thing, similarity search. Instead of exact matching, we can find data similar to the input data. Number 2, high speed. Searching in vector data is much faster and more efficient. Number 3, wide applications. From recommendation system to image searches and medical data analysis. And for this reason, vector data is very important and you can use your project. Comparison with traditional databases. In traditional databases, data is stored in table, but in vector database, data is stored and managed as vector in multidimensional space. Advantages of vector database. Similarity search. efficiently find data that is similar to the input, management of complex data, handle images, text, and video seamlessly, high speed and scalability, optimized for performance and scale. Data storage. Vector embedding represent data as a numerical vectors, and this is a vector embedding. This is a part of data storage in vector database. Indexing method. Organized vector database for fast search, and index method like hash method and another things for using these methods for fast searches. Storage formats. Storage data in flat files or distributed systems. Metadata storage. Add label tags for filtering. And number 2, indexing and retrieval in a vector database structure, internal structure. For one thing, I want to say approximate nearest neighbor. For example, this method prioritizes speed and scalability over exact matching. It finds close enough result quickly, which is ideal for large dataset. Number 2, exact nearest neighbor, ENN. This is an algorithm, exact nearest neighbor. In another video, I want to show how to work this and how can writing coding and programming what this algorithm provides highly accurate results by checking all stored vectors, but it is slower, especially with large data sets. Clustering. This processes group similar vectors together, reducing the search space and speeding up the retrieval processes by narrowing down which group to search. Search optimization. Techniques like multi-threading and GPU acceleration are used to improve the speed and efficiency of searching through large data sets. And I want to show you similarity metrics. Similarity metrics, we have a multi-algorithm for using similarity metrics. One thing, Euclidean distance. This method measures the direct straight line distance between two vectors. It's commonly used for spatial data and vector space. In the image, you want to see this method. Cosine similarity. Measure the cosine of the angle between two vectors. This is typically used in text or NLP tasks where the magnitude of vector isn't as important as their direction. Dot for dot. A measure of the alignment between two vectors, often used in machine learning to understand how similar two data points are. And Manhattan distance algorithm. Similarity to but some the absolute difference between dimension, useful in the grid-based or textable style space. Manhattan distance we can use in this section. Query engine. Query vectorization. Convert the input like an image or text into a vector using same embedding model that was used for string data, ensuring compatibility. Search algorithms. This algorithm defines how to search through the vectors. They balance speed and accuracy depending on the query. Result ranking. Once the search is completed, results are ranking by similarity to the query. The most relevant results are the returned first. And real-time queries. The techniques like caching and optimizing for low latency ensure that users' queries are handled in real time, providing a fast response. This is all algorithm in a query engine internal structure vector database. And I want to show you distributed architecture. One thing, sharding. Splitting data into smaller, manageable chunks or shards distributed across different servers, which improve scalability and performance. Number 2 is replications. This creates duplicate copy of data across multiple nodes to ensure that data is available, even if one node fails, thus providing high availability. Number 3, load balancing. Distributes incoming queries evenly across servers or nodes to prevent any one node from becoming overloads, improving overall system performance. And number 4 is cluster management. Uses tools like Kubernetes for managing distributed cluster, ensure efficient resource allocation, and monitoring the health of the systems. Integrations with machine learning. Embedding models. Machine learning models bear resonate that convert raw data into vector embedding for easier storage and search. Fast feature extraction. This involves extracting meaningful features from raw data, such as image pixel or text tokens, and converting them into a vector from storage and retrieval. Number 3, pipelines integrations. Integration the vector database into an ML pipeline ensures that data flow seamlessly through the system, enabling continuous learning and real-time data processing. And number 4, feedback loop. Using user interaction and feedback to retrain models, allowing the database to continuously improve its performance and the quality of its embedding. And performance optimization, the internal structure vector database. This is a part of internal structure. Caching. Frequently accessed data is stored in memory using readers to quickly return results without having to recompute them. Batch processing. Handling multiple queries or data update at once, reducing overhead and improve system efficiency. Asynchronous tasks. Performing non-urgent tasks in the background, allowing the query engine to focus on real-time query and reduce wait time. And finally, hardware acceleration. Using special hardware like GPU or TPU to speed up vector computation and increase the throughput of the system. Latency reduction. Techniques that optimize query response time, including pre-computing similarity score or improve network routing. Thank you for watching. In another video, I want to show you how we are coding, how we can coding these methods and make a vector database in your program. Please subscribe to me, and I see you in future video. Bye bye.